Hello. All right. That's a good start. Okay. I'm going to assume that hello, Maisha. That's awesome. I should say hello. And you guys can't, and hello. Oh, I like the front. Hello, Nicola. And you can hear me. Yes, people. Could someone confirm?
Yes, we can hear you.
Awesome. Oh, and thank you. She used her voice for that. Thank you, Alyssa. That's great. Okay. Excellent. Thank you. So it's been a long time. Okay. Hello, Maisha. Hello, Nicholas, and everybody. Hello. Hi, Catherine. And thank you, Catherine. And good afternoon, Althea. And good afternoon, direct message person. Thank you. Good afternoon, everybody, and Andrew. Yeah, and thank you, Maisha, for the answer. Good afternoon, Catherine. Good afternoon, She. Hi, Leslie. That's awesome. Good afternoon, Rachel and everyone. Hello, Alona and everyone. And thank you, Rachel. Oh, wait, are there two Rachel? Wait a minute. Oh, no, right. Duh. Okay. Thank you, Rachel. Good afternoon, Lisa. Good afternoon, Zimin. Hi and good afternoon, Elizabeth. Good afternoon, Jay Lynn. Hello, hello, Ruby. Hello and good afternoon, Eric and everyone. Good afternoon. Good afternoon, Jessica. Good afternoon, Aliyah. Wait, no, am I saying it right? No, we talked about this. Hold on a minute. Alia. I think it's Alia. No, it's Aliyah. Darn it.
Alea.
Oh, say it one more time. Alea, I'm sorry. Thank you. And thank you for correcting me. Yes. Yes, we did talk about that. Okay. And what up, John? Thank you. And good afternoon, Starnisha and all. And someone's entering. Hold on. Sorry. Okay. And hang on a second. Hang on. Oh, there are two Catherines. That's right. I have to remember that. Okay. So it's good to see you all. All right. It has been a long time. Wait, I think people are still coming, but hello. It is good to see you. I know things are crazy. I don't know if I said hello, Manoj. I don't know if I said hello, Lisa. I don't know. I think if I missed anybody, hello, Nicholas. I don't know if did I say hello? Thank you. Totally caught that. Thank you. Okay. Okay. Did I say, I think Starnisha, I think I've said hello to everybody. Oh, wait, there's a bigger screen. This is a very big class, which is good. Good in all respects, except that it does. Oh, and Michaela, hello. Is there anybody I didn't say hello to? I feel like there is, but okay. But it is good to see you all. And it's really good to say, and a lot of you, again, thank you. I almost forgot because it's been so long. Like a lot of you really do show video and pictures and stuff, and I really appreciate it. Okay, let me start with. Oh yeah, and you're that class, right? Okay. So I owe you a lot of things, largely thanks. You guys are way ahead of me. I'm behind you. I mean, all of you are doing right things left and right. And it is a very big class. I'm going to use that as an excuse, as a partial excuse. For the fact a lot of you have not even gotten, okay, wait, let me back up. None of you have gotten back homework 3. I'm aware of that. None of you, and we're not nearly up to it, but still, none of you has gotten back homework 2. I'm aware of that. So if you haven't gotten it, it's definitely not personal or anything. Homework 1, a lot of you have gotten it back at this point, but a lot of you have not. There's no rhyme or reason to that. It's like alphabetical or whatever. I may stop in the middle of this class and acknowledge those people who I know have turned in it, but still haven't gotten it back yet. And we're going to talk a lot about homework 1 today. Let me just remind you still to all of you, like I know who's turning in things when they're due. I do know that. But let me remind you again to all of you, if you're getting things back, if you're starting to get things back, and you will if you haven't, if you're starting to get things back, please remember if you get anything less than all the points, that is just a way of saying to you that you still can get all the remaining points if you just make revisions and resubmit. There is no time limit on that. There's no time limit until I otherwise say so. On the regular physics homework problem sets, like you can keep handing them in until you get all the possible points, or you cannot if you want to. But so please, if you are starting to get scores back, if they're lower than you're used to or lower than you'd like, don't stress about it. It's not a punishment. It's not a percentage. It's not the end of the road. It's just saying there's still more points for you to get when you have time to do so. When in doubt, I would probably always, well, yeah, so there's that. I know we've only talked about, we're going to talk about homework 1 today. And we're going to talk about what I'm looking for in homework, like what the acronyms mean that I'm putting on your homework, or like why I take off points when I do. So again, if I put handwriting on your homework and you don't understand what I'm saying, it'll hopefully be clarified today. That's one thing. The other thing is, I know it's all a little bit nutty and a little bit spazzy because once again, this week, we don't have school this Wednesday. Like you don't have class again, just because nobody does. So once again, I'm not going to see you for a full week. What does that mean? It means I might somewhere in the intervening week post homework 4 for any of you who still want to try and start seeing what's coming next and stuff. But let me make it clear. We have 3 homeworks to get through. I'm not even going to finish going over homework 1 today. I can tell you that, right. We're not even going to finish homework 1 today. Things will speed up more and more in the course. They'll get more interesting to those of you who are already bored, or they'll get more clear or something to those of you who are confused. But we're going to continue going over homework 1 today. That means 2 things. It means 1, there's still opportunity to still hand it in or make fixes as you see fit based on today. But number 2, it means there's no way we're getting to homework 2 and 3 by next Monday. Okay. So even if I post homework number 4, I'm telling you right now, I do that so that, you can see what's happening and so we don't all fall behind, but you don't have to do it. We're not going to get up to homework 4 by next Monday. It's just, there's no way that's going to happen. So don't take it as a stressful thing. If you see homework 4 posted up, but you already got back homework 1 and you want to fix a lot of things on it and turn it back in for more points, that would be my recommendation. That's a better idea than worrying about homework 4. Or if you're like, I haven't even gotten 2 and 3 yet, why am I worrying about 4? You're correct. Don't. Like, if I posted it, it's just so that we can keep pace. But right now, most of you are ahead of me, and that is a good thing. Don't let that stress you. Let that make you realize that you're in the right place at the right time and you're not falling behind. Also, let me say, since it's been so long, last Wednesday was one of those funny Wednesdays where which will happen from time to time. I know there's been some confusion about this. Mondays should always be normal. Oh, sorry. Oh, wait, let me see. Sorry. Great question in the direct chat. Just to pause for a second. So someone's asking in the direct chat, they notice that, well, I'll just read it. I'm not going to read the person's name, but it says, how do I go about uploading proof of my voice for that one module or that one portal? And it's a very good question. What they're referring to is that there's at least one game portal that gives you points if you ever use your voice in the class. Like the game portal is called Speak Now or Forever Hold Your Chat, I think. Like dumb name, but that's what it means. Is like if you ever actually speak instead of just using the chat, and you can remind me of that fact, then you get points for that. You don't have to prove it. You definitely don't have to prove it. Just if you say something today or like any day before October 1st, if you say something, just jot down like on a document, just open up a fresh document for that portal. Say you said, oh yeah, professor, we don't have class on Wednesday. Or say you said the answer to question 3 is average velocity. Just write down on the thing, I'm the one that said we don't have class on Wednesday, or I'm the one that said the answer to question 3 is average velocity. You don't have to prove it. You're just like reminding me and noting it. And believe me, I'll know that you're telling the truth once you remind me of that. And it would be crazy to lie about a thing like that. Like I'm sitting, you know, don't make up something. Don't write down like I used my voice to compliment your wife's dress. Like if you didn't do that, like I know if no one said that, then no one. So you know what? You don't have to prove it. You just have to like be honest and just remind me of it. Just give me enough specificity that it jogs my memory. Oh, cool, cool. Thank you. So in fact, let me also say that the person that just wrote that question in the direct chat, right when I just said that, they just wrote, okay, that makes it clear. Thank you. So please remind everybody, the fact that they did that, even though it was direct. So I'm not saying the person's name, but like the fact that they said, okay, got it. Thank you. That counts as closing a conversation. So that person can, you know, submit points for the using the voice thing and can submit for points for the closing the conversation thing. Just to remind you, because I know it's been a long time. Also, just to say, I think on almost game, I think a lot of you are understanding this whole class participation game. I mean, I know it's not game as in like that it's wildly fun. It's not wildly fun, but it's a game in that it's just all about accruing points, and that there's different ways, whatever. What was I going to say? All of you seem to be understanding, or I think most of you are understanding how the class participation game thing works. And I hope you'll find with that, I think I'm caught up to you. Like anybody who's turned in anything, like game turn 1, game turn 2, or any of the other game things, I think you've all gotten those back. So that just to show we are communicating, like, and all these things are adding up, and I appreciate that. Game 3, you know, for this class is due tonight before midnight. If you want to get all 5 points, if you turn it in tomorrow, you can still get points, but you get 4, not 5, blah, blah, blah. Okay, there was one thing I was saying before. Oh yeah, so last Wednesday was weird. This will happen from time to time because I do have a weird conflict in my teaching schedule. I literally am supposed to be teaching 2 classes at the same time. That could have never happened back in the day. But now with COVID and with all this remote learning, technically these courses are, you know, they're what do they call it? Like synchronous, asynchronous, mixed, right? Like technically we have the right to sometimes do class in a non-synchronous way. So every once in a while, every couple of weeks, sorry, someone's here. Let me just let person in. So I'm apologizing and thanking you in retrospect. I may or may not have warned you. I don't even remember at this point if I did, but every once in a while on a Wednesday, like every couple of weeks on Wednesday, I will give you a warning that we won't be meeting that day. And I will tell you to watch a video instead, like the video of the other section that met in the morning. I'll try to give you a little bit more of an advanced warning than I did last time. And so every couple of weeks on Wednesday, sometimes that will happen, that you watch a video instead of us being all together. That's just an unfortunate consequence of life being what it is these days. Because I gave you such short notice last time, because I didn't think I sufficiently warned you like until that day. That's why I kind of scrambled and made that whole weird, like, I don't even remember, like urgent thing where I was basically like, if you could just acknowledge that you got this message and you get it, then I'm giving you tons of points for that. And I meant it. And all of you who did that did get the points. And I really appreciate that. Like, I totally meant it. I hope I don't have to be that crazy and spastic again, but I'm sure I will be. You all did the right thing. Like, you did exactly the right thing. You just acknowledged to me that you got what was going on. I appreciate that. Then hopefully you did watch the video. We'll find out today, I suppose. But that's not the last time that will happen. Again, it just will hopefully happen in a slightly less spazzy way. But because of that, again, I know we haven't talked about material in such a long time. If you're looking at these homeworks and you're like, I don't even know what he wants here, we will start catching up. And that's why you have infinite time to correct the homeworks, you know, because I get that. I understand. Okay. I'm sure you want to hear. So I want to get to material soon. Right. I'm going to do today's class. So today we're going to get back to going over homework 1. Like, in theory, you watched that video where I started going over homework 1 with the other section. In theory, at least you saw me starting to provide a sample solution to the first, I think, 4 questions. I am going to assume that you watched the video. I am going to assume that I'm not talking completely out of nowhere to you right now. So we're going to pick up from question 5. Okay. So we're turning to homework 1 now. We're going over it again. We're going over it, whether you turned it in, got all the right answers, or whether you turned it in, got all the wrong answers, whether you turned it in, got points back already, whether you turned it in, didn't get the points, whether you didn't turn it in. I'm hoping that what we say today is of benefit to all of you, even if it is just to show you actually ideally how to do the future homeworks. Okay, today is a little bit more maybe still about how to do physics rather than like the physics equations themselves. I mean, we'll see. But oh, excuse me. Hold on one second. Okay, right. So we're going to go back to homework number 1. Obviously, please do stop me at any time with any question about anything, private or public. Like, I don't mean to lecture, but well, just, you know, it's going to be spazzy like this for a while until we like get into a groove of meeting twice a week. Also, just note, I've probably said this before. I spend a lot of time on fundamentals, as you can tell. Like, if I were a piano teacher, which I totally am not, I would probably spend months and months on scales and it would drive everybody crazy and I would have no students left. But I would still think it's worth it. Like, it's the more time we spend on fundamentals, the more we can then ramp up and do hard things and learn how to apply the fundamentals quickly on our own. Why am I saying all this? Is that anything I say today about like how to do the homework or where you're losing points or why I wrote what I did on the homework, please also indulge me and understand that this all applies to physics 204 as well. Like, even if you don't have me as an instructor, it applies to physics, whoever you have as instructor. And most likely, if life is, I do hope you all join for physics 204 again next semester. And I almost always teach all of the lecture and recitation test sessions in physics 204. So consider this an investment in 2 semesters worth of habits. That said, what I'm going to do now, okay, what I want to show you now, like we are talking, this is in the context of homework 1, but before I even get into equations or the particular questions, I want to show you what my method is for answering a physics question, like what to do, what to do in answering a physics question. This is particularly important ultimately when you get a physics question that you don't know how to answer. This is my 5-step method for what to do when you don't know what to do. So it's ultimately, I think, helpful for guiding your way when you feel like you have no idea what to do. However, the only way it works, or the only way you'll believe it, or the only way you can practice it, or the only way you know the method is if you even apply it when you even think that you do know what to do. Okay, so what I'm in short saying is I'm about to show you like my 5-step method for solving physics problems. None of it's going to strike you as surprising. It's all kind of like 7th grade stuff in a way. What the only surprising thing is maybe that as a college professor, I'm actually requiring you to do it. like in other words, I'm going to tell you the 5 steps that I expect that constitute showing work. And this is what I'm grading homework based on these steps. So you're going to find, especially those of you who have gotten your homework back, and again, I know many of you have not. But if you get your homework back, you may find that it looks like you have the right answers. I might even check your answers, or put checks, or it might be, or you might find out today that you clearly have the right answers. And yet I have all these acronyms written on your homework and like -2, -2. It's because I expect these steps, even when you think you have the right answers. I don't care. I want these steps. It's not that I don't care. Like, I'm impressed, but whether or not you think you already have the right answer in your head, I want you to show me these steps. And there's 2 reasons. Well, there's 3 reasons. One is this way, even if you don't get the right answer, you can still get full credit on the homework. Like, it really is not about the answer. It's about the process. I'm sure you've heard that a million times before, but I mean it. So here are the 3 reasons why I grade on the process and on the steps, at least for homework, not on the answers. 1 is that way you can get full credit even if you don't get the right answers. 2 is that this is the steps to follow when you don't know what to do, which tends to start happening soon in physics. Like, we're going to get there. Believe me, we're going to go faster and faster. We're going to get to a point where people are going to look, and maybe you'll feel this way the minute I post homework 4. In fact, maybe many of you will look at it and be like, whoa, this was all boring and clear up until now. Like he was like boring me to tears because it was like so easy. Maybe some of you are saying, but then like, what is this homework? Like some of you might have that reaction and you might look at the first question and be like, I don't have any idea what to do. Like, dude, I understand it when you're saying it. There's a common reaction. Well, people will say, I understand what you're doing when you do it in class, but you expect me to do this on my own before I come to class? Like, no way, dude. And what I'm saying is if you have that reaction, if you have a reaction of, I have no idea what to do here, I'm telling you now what to do when you don't know what to do. I'm telling you the steps in which to engage in order to get you closer and closer to an answer, whether or not it's the right one. So reason number 2 is this is a method to follow if you think you don't know what to do. But reason number 3 for this method is, as some of you will find on homework number 2, and I'll get to the second, the third reason for this method is sometimes we think we do know what we're doing. Sometimes we think something is really simple and we have the answer in our head, and it turns out that's not the case. And if we would follow the method, we would see the sidebar or just side example, just to keep people interested. I might have mentioned on homework 2, which you haven't gone back yet, but homework 2, the last 2 questions of homework 2, like average speed, there's a question about something going up a hill and something coming down. You might recall like something goes up a hill at 40 kilometers per day, or 40 miles per hour, 40 somethings. And then it comes down at 60 somethings. I think it's kilometers per day, but whatever. Something goes up at 40 and then it comes down at 60. And I ask, what's the average speed for that journey? Just so you know, the answer is not 50. And I don't take off points for getting the wrong answer. And I certainly don't shame anybody for getting the wrong answer. I don't think anybody should feel ashamed for getting the wrong answer. But I do want you to know that if you follow the process, you would see that the right answer is not 50. Like, even though it seems like the right answer should be 50, it's not for that question. And following the process will lead you to see that. Similarly, on the last question of homework 2, it might look like the answer is 120. Is that 100? I think that's what a lot of people think the answer is. I can't remember the numbers now, but I think that's. Yeah. It seems like the answer to the very last. And again, if you don't know what I'm talking about now, don't worry about it. And if you got the right answer, good. But just so you know, the last question on homework 2 might seem super obvious if you just do it in your head. It might seem like the answer is 120, but it's not 120. And it's not because it's a trick question. It's just a tricky question. But you can't even see that it's a tricky question unless you do this process. So here's the process. Here's the process. And here are the acronyms for grading and stuff. Whenever you get, and it's a 5-step method. It's like the scientific method for doing an experiment, only it's the scientific method for solving a problem, at least a physics problem, at least according to me. Step number 1, DFP. What I mean by DFP is diagram and fact pattern. In other, like it says right here, right? Write down the givens of whatever the problem are, like before you do anything else. Even if I provided them to you, provide them back to me in your way. If I gave you a diagram, give me back a diagram. Will your diagram be very similar to mine? Sure, it'll be very similar, but will it be identical? No, it won't be identical unless you copy and paste it, which we don't want you to do. I want you to just spend enough time drawing the diagram that you show yourself and me that you see all the relevant information of the problem. Sometimes I give diagrams and that helps people remind people that they've got to give me a diagram, but sometimes I don't. Either way, you want to always start with a diagram. By the way, another reason for what, and when I say diagram, I really should say, I'm sorry. When I say diagram, I really mean, excuse me. I'm still going to keep the acronym DFP, but by diagram, I mean any kind of picture, any kind of sketch. Like, in other words, it doesn't have to be a technical diagram. It doesn't have to be a graph. It doesn't have to be a free body diagram or something. Just like any kind of sketch. But the key of the diagram is that you label things in the diagram, and those labels end up defining the variables and the constants that you end up using in the math work of the problem. Remember, again, we're still starting the year here, even though it's a very spazzy start. So everything's still kind of like in English here. Things start looking more and more mathematical, more and more symbolic as we progress through physics. Things look more and more like equations. You'll start having a lot of work that you show me that'll be like x equals 1 f at squared plus v naught t, blah, blah. Well, if I, the reader, I'll need to know what you mean by X or what you mean by T or whatever it is that you're playing around with in your problem solving. Where do I find out what these things mean? I find out because you use them as labels in your diagram. So the diagram really like defines the terms of the problem. And then you should also write down whatever facts are given by me or in the problem. So first you present the givens in your way. It'll be similar to mine, but it won't be identical. Okay, that's the first step. And that's what I mean by, so if I wrote anywhere in your work, if I wrote DFP -2, I'm saying please start with the givens. Even if you think I already know them, you need to show me that you know them. And also don't assume that the person reading your problem is the person who wrote the problem. Anyway, so DFP means diagram and fact pattern, i.e. the givens. But everything, well, anyway. Ideally, I'm going to try to put this all into a typewritten sheet something, but this is the way it is right now. All right, so that's step A that you got to do, even if you think you know the answer. Then step B, as I think I explained this last time, but I'll often write on people's homework, WIQ means what is the question? So first you're presenting the facts, the situation, then you're presenting the question. Now, how do you know the question other than whatever I said the question was? Right, you're getting the question from me for sure, but you're putting it in your own words, please. That's what like YOW stands for. And I'm not trying to make this all into a whole other language, but there's a lot of papers to grade and whatever. By YOW, I mean your own words. So it says here, please do not copy paste. You totally can abbreviate, right? So, well, I think we said this last time, but like if I write in my long words, like at the very first instant of the instructor's walk back and forth across the room, what is the instructor's velocity? Let's say I say that, right? You don't have to write all that back. You could super abbreviate. Abbreviation is good. You could be like at t = 0, v = question mark, right? You just want to capture the essential information of the question. And the more you can abbreviate and leave out all the extraneous stuff, the more you've shown that you really know what the question is. So it doesn't need to be in my words. It shouldn't be in my words, but give the question before you answer it. It's really important. Here's the thing, when people think they get the question immediately, when people think they know how to answer it, they usually skip this step because it seems like a stupid waste of time. The thing is, when people don't understand how to ask a question, then they end up skipping this step because they've gotten in the habit of skipping this step. And that's exactly the time you shouldn't skip the step. If you don't understand a question, the first thing to do is try to communicate what it is. Then you'll see what aspect of it you don't understand. Anyway, so put the question down. Don't copy paste, please. I was going to say one other thing about this. Yeah, okay, I'll go on. No, all right, I'll say I can't resist saying this. People often do, and again, this is all I know it's not interesting. Like I'm not sitting here like, whoa, my mind is being blown about the universe hearing this. And I know it feels like 7th grade in a way. But it's not because of anything any of you have done wrong or anything. This is how I do hard problems. The harder something is, the newer something is, the more I want old, reliable life rafts to get into, right? I mean, the choppier the water is, the more I want to study a life raft. So whatever I learned in 7th grade or kindergarten or something about how to break down a new situation is what I want when I get to super advanced new situations. Like the more advanced, the more sophisticated a new physics research scenario is, the more I feel dumb, right? I don't sit there and feel smart just because what I'm working on is some like really high level smart thing. If it's high level and smart seeming enough that I can't do it or that it's never been done before because it's research and it's original, right? The more in the face of it, I sit there, I'm like, I don't know what to do. This has never been done before. I don't have a script to follow. No one's giving me an algorithm, right? So like this, like the more high level stuff you're working on, the more low level you feel. So what you want is the script that we follow when we're feeling low level. So we write down the question. What I was going to say about that is people will often say like, well, all right, I can't copy paste. Fine, I can't copy paste, but aren't I going to end up writing like pretty much what you wrote, Yaverbaum? I mean, hopefully you wrote the question in a reasonable way. Hopefully you didn't add a lot of extra words, like just to trick us and just to see if we could abbreviate. Like, hopefully you wrote the question in pretty much the simplest way it could be written. So how is it possible that my question is not going to look exactly like yours? Fair question. Glad you asked. Here, and your question will be similar to mine, but it won't be identical. And here's how to guarantee. All you got to do to know if you've put it in original enough of your own words, this is what always to do. If you want to know whether you've taken my stuff and converted it sufficiently to your own original personal language, is just do this. Look at my question and then look away from it when you go to write down the question. In other words, when I say don't copy paste, I also mean don't mentally copy paste. If you look at my question and you're like, oh, he's asking what the velocity is. Like say I say, what is the velocity at t equals 0? And you're like, okay, he's asking what is the velocity at t equals 0. And then you go turn to your piece of paper. And without looking at my piece of paper, you're able to write down what is the velocity at t equals 0. I promise you, just by doing that, just by writing it without looking, you will change just enough words to show that it's filtered through your head, not mine. You'll change just enough. You'll change just enough that it'll be clear that it filtered through your head, not mine, if you're not looking. But if you actually look at my question, you won't be able to come up with any new way of saying it. Like, if you get what I mean, like, just trust. The whole thing is to make sure that these things filter through you before they hit the paper. And as long as you're not looking directly at mine, it will. If you have to keep looking back to mine to see how to write it, that probably shows you're not retaining the question, like you don't actually get it. And that's why we're going through this exercise. Anyway, all right. So first is diagram fact pattern, i.e. the givens, DFP. Then WIQ, what is the question? Okay, that's the second step. And each one of these, oh, sorry, yes. I'm sorry, go.
So when we write the assignments, we're supposed to write down the question, right?
Yes, please, absolutely.
So we're not supposed to just write the same way it words it in the assignment.
Right. Don't write it verbally. That's right. Like it'll be very similar, but don't literally copy the words word for word.
Oh, I didn't know that.
Okay.
Yeah, see, I didn't know we were supposed to come up with our own way of saying the question. I thought that didn't matter. I thought it was just answering the question.
No,
I know you said you wanted to see the question, but I don't know, you meant that you wanted us to make a completely new question.
I totally understand. No, and I'm glad that John is saying that. Listen, this is to everybody. I totally understand. There's no way you could have known this walking into the class before you met me. And I totally believe John. I believe John two things right now. First of all, I believe that he authentically was trying to follow instructions like before today, that he actually did hear me say, like, I need to know the question. And that he authentically tried to do that, but then didn't realize I meant, like, I don't want it exactly. I want your version. I totally believe him. I also believe from the way he's saying it right now, that he gets now what I'm saying now. And this is the deal to and I mean that. And I mean this to everybody. And this is why I want to keep saying this. Any points that you lost on the first homework or the second homework, I'm trying to explain now to everybody so that you can get them back. The points that I put on your homework is not meant to be a punishment or criticism, really, folks, everybody. Like, if you got a 12 out of, or say you got a 10 out of 20, I know if I were in your shoes, if I got a 10 out of 20, I'd be thinking, oh my God, that's 50%. So I just totally failed the first homework. So far I have an F in this class and the professor thinks I'm an idiot, but I totally tried to follow the instructions. It's totally not fair. Like, the professor totally didn't say this before. And now he's saying, like, no. Like, I get it. I didn't say, how could you know? I didn't say it before I met you and I have a very particular way of doing it. I mean, all professors do, just some of us are more honest about it than others. What I'm saying to everybody is, we use the homework to find these things out. I'm telling you now, and even if I did tell you before, I understand it takes it takes practice and 50 repetitions of anything to figure anything out. So nobody, certainly not John, but nobody else. This is not me trying to justify why I'm criticizing you. And you guys don't have to justify why you didn't do it perfectly this way the first time. I know everybody's in good faith. I totally know for a fact, actually, because I now know John well enough. Like, I've heard from him enough. I've seen his homework enough already to know he's not trying to, like, gaslight me. I totally believe him. that he's like trying to do what I'm saying. And then he's like, oh, I thought you were saying this. Oh, now it turns out you're saying this more specific kind of weird idiosyncratic thing, Yaverbaum. Like my other professors don't do that. Why was I supposed to expect that? And you weren't. Like, that's why I'm explaining it now to everybody. It took me a long time to develop these habits and realize they were necessary for excelling in physics. And we have time together to work them out. So I'm telling everybody, no, if you got it, and I'm not saying John did get a 10, by the way, I'm just using that as an arbitrary example. But if someone got a 10 on a homework, or if John didn't get a perfect 20 and doesn't like the score, all this is all an explanation of just how to get the points back now. Like, and they won't be late and they won't be with shame. They're just like, we're trying to figure this all out before we get to the exam. Because again, the truth of the matter is physics can start looking hard. So we want to figure out how to make it easy while it's still comparatively approachable. So John's question is a great one, like, or his point, well taken. And I assure everybody, you're all in the right place. You're where you're supposed to be. No one has messed up yet. The only person who's messed up is me for not turning back homework 2 and 3 yet, honestly. I mean, okay. So yeah. And anyway, you'll practice again and it might still not be perfect. And we'll just keep doing it until, okay. So yeah, so step A, you give a diagram, you give the fact pattern. Step B, you put what the question is. Again, if you're doing this right, you're going to feel like you're wasting your time at first. You're going to feel like you're just like you probably feel like I'm dragging this all out in class. At first, we're just trying to break everything down into steps, stuff that doesn't seem like it needs to be broken. And again, let me say, and I know I've said it a million times, the reason we're slowing down even things that don't seem too fast is so that we can see the movie in our mind of what steps our mind goes through when it does know what's going on. If we can really see what that movie looks like, or what our mind does when it knows what's going on, then we've got a movie to rely on for when our mind doesn't know what's going on, right? This is the formula, the method for what to do when you don't know what to do. So again, all right, so it'll feel stupid doing it when you do already think you have the answer. I get that. I am asking you to put extra time into something that doesn't feel like it needs the time. It's an investment for later. But okay, so step C, so sorry, A was like DFP, diagram and fact pattern. Step B was WIQ, what is the question? Step C is GDP, not gross domestic product, but general definition and or principle. Okay, this becomes very important. This is another step that people tend to skip when they don't think they need it. And then when they need it, they don't know how to do it. What I mean by this is start with triple equal signs and move your way to double equal signs. What do I mean by that? I mean, and you might want to write this down, even though I didn't write it here. Like, say my question, say we're talking about homework 1. In homework 1, I believe it is question 6 or something, is what is the average velocity of the instructor, or question 2, I'm sorry, question 2 in the homework is, what is the average velocity of the instructor for the entire 9-second journey? I think the whole journey is 9 seconds, right? Or sorry, the entire 8-second journey, right? So question 2 is, what is the instructor's average velocity for the entire 8-second journey? Now, first of all, for that, when you write down what the question is, you could just write something like from t equals 0 to t equals 8. V bar equals question mark. Like, you could just like write that, because as long as I know what the question is, okay, you've written it and you have the diagram. So now we're on step C. What I'm saying now is what a lot of you would do on the homework, especially because that question wasn't hopefully too stressful. What a lot of you would do is you would do something like, okay, average velocity like V bar equals -9 over 8. And you get like -9/8 feet per second. Now that is the correct answer for anybody who's trying to follow along. For question 2 of the homework, the correct answer for the average velocity is -9/8 feet per second, or in other words, -1.125 feet per second. We can go back and talk about why that is if you want in a couple of minutes. I think I talked about it in the YouTube video, but whatever. But like, first of all, that is the correct answer. So if you got that, that means you are doing something right and you are understanding something in physics, which is good. The answer to question 2 in homework 1 is -9/8 feet per second, or -1.125 feet per second. But here's my point. Oh, sorry. I'm sorry. Yes.
What do you mean question number 4?
Oh, sorry. Is it? Maybe I do. I'm sorry. Oh, you're right. I'm totally, yes, I do. Yes, thank you. Good, correct. That totally points. And I need to open up a portal for like when people correctly correct me or yes, totally right. Thank you, Ruby. That was Ruby, right? I think that was Ruby. Sorry. Yes, I'm talking about question 4. I'm sorry. And I could pull up the screen. I just don't want to. Yes, question 4. Thank you. Is what is the average? And that also shows that at least one person was paying attention. Thank you. So I asked, what is the average velocity for the 8 seconds? And it's indeed, the correct answer is -9/8 feet per second. But here's the deal. I did take off points. If you just like wrote, even if you did the other steps, but if you then just wrote, well, V bar equals -9/8. I think there's a step being skipped there that you might think is so obvious that it's not worth writing. Not you, Ruby, like you, anybody might think, but I want to stress it's not obvious. And here's the step I'm talking about. Before your brain, even if your brain thinks that question's really easy, if your brain got to saying, oh, it's 9/8, that means your brain first had to go, well, what is average velocity in general? Oh, in general, average velocity is displacement over time. Like if your brain knew that it's 9/8, that's because your brain plugged in 9 and it plugged in 8. But why did it plug in 9/8? Like why didn't it plug in 21/8? Or why didn't it plug in like oranges over fish? Because your brain knew that if I ask for average velocity, what I'm asking for by definition is displacement over time. And then your brain said, oh, in this case, the displacement is -9 and the time is 8. So then your brain plugged in, and it might have done that all so fast that when you just went, that you did it so fast that as soon as you saw the question, you're like, oh, what's the average velocity? Oh, it's like -9/8. Like, duh. Okay. And you write down -9/8. What I'm saying is your brain just moved through a couple of steps super fast. So yay, you. Yes, you're smart. That's awesome. But don't now insult yourself. If your brain moved through those steps that fast, don't, like, you should give yourself credit for how many steps your brain just moved through. Don't say to yourself, well, I guess there were no steps. I guess my brain just like it was totally obvious. People always do that. They get something hard correct and they're like, well, that was easy. Well, everything is easy in retrospect and nothing is easy in advance. Your brain could only have known to put in 9/8 if first your brain recognized what is always true about average velocity, which is that it's always displacement over time. Then your brain applied that general truth to this particular circumstance, right? Those are steps. And you want to realize that those are steps because when we don't know what to do, those are the steps to fall back on. So what I'm saying is before you dive in and start plugging in numbers, like a really important habit in physics, especially as it gets harder and harder, and especially as physics starts looking more and more mathematical, one of the ironies is the more mathematical physics starts to look, and it will, and there's like a lot of integrals in physics 204 and like differential equations, like it gets heavy. But when it gets really mathematical, it doesn't get mathematical like Montessori arithmetic. Mathematics doesn't mean like 3 + 7. It gets mathematical like math, like your calculus class, i.e. like a lot of letters, not a lot of numbers. Math really ultimately means general relationships between quantities. It doesn't mean specific quantities. Like that's what counting means, right? So what I'm saying is we got to get used to the letters of math, the variables, the constants, the equations, if you like, the principles, the definitions, the things that are always, always, always true. We apply those first. We state those first, and then we apply them to the specific situation. So if I ask what's the average velocity, what you first do is say average velocity triple equal sign displacement over time. Okay, that's what I mean by a general definition and or principle. Like definition is a definition. And what do I mean by principle? I generally mean like a law, like Newton's second law of motion or something like that, right? You write down first whatever is generally, i.e. always true, then you apply it and make it relevant to the situation. So this is really important. What I'm really saying here, just to clarify this further. So anywhere on your sheet, if I ever wrote GDP and took off 2 points, it doesn't mean you got the answer wrong. You may well have gotten the answer right. I'm saying you skipped a step that I really want you to be aware of. And the step you skipped probably involved the triple equal sign, probably involved some letters. You probably skipped straight to the numbers. And we really want to get into the habit of not doing that. The numbers are just the particular data of some particular experiment in one lab somewhere. What we're looking for as physicists is the general laws that govern all labs, so to speak. So let me just add a page. I'll tell you what I mean. This is the two things. Again, everything I'm saying hopefully makes enough sense that maybe it even borders on not like, hopefully a lot of what I'm saying, you're thinking like, yeah, I know, I learned this in 7th grade, like I know. But what I'm telling you is these are the things that people know when they know them. And when they know, these are all the kind of things that when people do feel like they know what's going on, they know these things so well that they don't feel like they have to use them. And then the minute they don't know what's going on, these things go out the window. And they're not quite as obvious as they sound, like particularly this second thing where it says proceed from true to relevant, not the other way around. I do want to tell you, and you just won't know until you know really from experience, but the reason I have to say that is the big tendency, especially among successful, ambitious, hardworking, good science students, is that when a good, hardworking, experienced, successful science student hits something like in an exam or in a poster presentation or like in a journal article, if the minute a successful, good, like quark fearing science student hits a moment of panic, which we all do, right? Because we're doing science at the level that we should be, there's going to be challenges and there's going to be moments where we're like, I don't know what's going on, because like it's research science and no one's done it before, right? If you hit, or it's a hard class that you're taking in preparation for research science, when you hit that moment where you're like, oh yeah, I don't know what's going on, or it's in the middle of exam, I studied like all night, blah, 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 but now like I'm totally panicking because my entire life depends on this grade and blah, blah, blah. Oh wait, yeah, we're gonna, sorry, yeah, I'm getting to that. Yes, direct message. I want to finish. This is all about how to do number line, but yeah, I'm going to go back to number line as soon as I finish this. I think I tried, hopefully I tried, but yes, totally. Sorry, and I'll try to speed this up if that's the point. All right, I'll try to speed this up, but look, the point is when people panic, what they tend to do is try to write down something that they think is relevant, and then they contort it into something true. Don't start by writing something that's true. Like if I say, what is the average velocity? Just write down the definition of average velocity first. You're going to get points for that, even if you don't know what to do next. If it's true, it's true. It can't be wrong. So always start with something that's just generally true. So at least you're not going wrong and you're getting points, and it'll guide you to the next thing. So then the next step is, okay, so is this, all right. So that, and there's two, so for those of you who are asking about number line, yes, I'm going to get back to number line. Wait, what time? Yeah, we still have 25 minutes. Yes, I will get back to number line starting with question 5, because you guys are already up to question 4, I believe. But this, if I already graded your number line and wrote these marks all over it, these are what the marks mean. And this is what I want to see in the future homeworks. So after you do GDP, like general definition of principle, then comes PAW, particular application and work. This is what most of people tend to consider. This is the part most people are most used to and most comfortable with. Whenever anybody, any science professor or anybody says, or math professor says like show work, this is the kind of work that people think they're expecting. Like this is the plugging in numbers part. I'm saying if you just dive right into plugging in numbers, you've skipped a lot But yes, once you've written down average velocity, triple equal sign, displacement over time, then now it's time to shift to a double equal sign. Now you could say, the displacement's -9, the time is 8. Now you plug in numbers and start manipulating the units and whatnot. So this is like what you consider the work. I'm just saying there's more work that happens even before this work. But so pause, particular application and work. This is the plugging in numbers part. Again, please notice it's like step 4 of the process. If I ever write on your homework, so if I write paw, that's what I mean. If I write www, I mean why, what, where, from. That basically means I think you skipped a lot of steps or something. Like if I write that, just means there's work that needs to be shown here. Okay. All right, I'll try to speed up because I know this is starting to frustrate people. But tell me if I'm going. Well, anyway. Then finally, the last step, FAC fact, the final answer circled, please. Like, so now we've done all this. You've got the givens, the situation, you've got the question clear, you've got the general principles or definitions that are central to the question, you've got the particular application of those principles to the numbers, to the values of the situation, and now you're finally at a final answer. So give me the final answer and like with units. And as a complete statement, like if my question is, what's the average velocity? Then your answer is average velocity equals -9 feet per 8 seconds, right? Like your answer is a statement, is a complete thought. It has an equality sign in it. It's not just like a fragment, as a complete statement. So if I write FAC, that means I need the final answer. And by this point, if you've done all these steps, I don't care if the final answer is wrong, you're still getting all the points. But I need to see a final answer, and please circle it. If I write FAC or PCA, either one, it means circle the answer, please. Highlighting is fine too. Many of you are bold facing answers. That's okay. It would be, but it's even clearer and better if you make a point. And there's many reasons for this. It's not just to make my life easy, although that's part of it. It's also like you want to view all of physics problem solving as a conversation. Like you're presenting the problem, you're presenting the work, then you're presenting the final answer to the problem. Like, and you want to commit to those bookends. But okay, so that's it. Those are the 5 steps that I'm looking for in any homeworks, all homeworks. From now on, if I write any of those acronyms and take off points, that's what they mean. Okay. But now I know, I hope that's clear, and you can like rerun the video later or whatever. And again, it's all second chances, third chances, fourth chances. None of this is meant to be punitive, but I know that it is also not interesting. So for people who are asking, like, are we going to get to number line today? Yes. Now I will get back specifically to apply this to number line. What I believe, stop me for a moment, but I believe, since you were asked to watch the video, I believe in the video I got through the first 4 questions. I could certainly tell you this right now. Here, I'll just say the answers to the first 4 questions but I believe I went over them in the video, and we'll pick up from there. But just so, all right, so back to number line. Now, again, I'm almost afraid to do this. I'm about to write down the answers just so you can check and make sure that you're okay. This is not work. This is just the answers, how I did the work and stuff I went over in the video. And then I'm going to pick, right? Like, it wouldn't be acceptable. It's not acceptable just to give me answers and call it your homework. But just so you can check, or you can know if you're doing things right, here, or just as a reminder, here were the answers to the first 4 questions. Okay, so just to pause for a second. So those are the answers for the first four. Again, I think I went over them in the video, but those are the answers. They didn't show the work, but those are the answers. I'm gonna move on in a second to the rest. So we have like 18 minutes, and we're just gonna pick up from here next Monday. Again, just keep going with the homework. If you've done 1, 2, and 3, and you think you've done them fine, you can wait to see 4 to come out or not. But all right, those are the answers to the first 4, right? I'm just gonna pause for a second.
Professor, is that a negative?
Thank you for asking. I totally appreciate it. In the very last one, in question 4, under average velocity, you mean, or which one?
For question 4, yeah.
Yes, it is a negative. Thank you for asking. And that's Mark. Yes, thank you. Awesome. And thank you for having a picture. Yes. So that very last one is negative 1.125 feet per second. And I'm actually glad that Mark or anybody asked about that. Yeah. For these first 4 questions, notice the displacement and the average velocity can be negative, like in general. And again, I just don't want to, I mean, I can try to explain this again later, but yeah, excuse me. Distance is just how far you go, how much space is traversed, independent of direction. Distance doesn't care whether you go forward or backward, north or south, left or right. Distance doesn't, but displacement cares about direction. Displacement is asking how far you go in what direction. So displacements can be positive or negative. And like in our number line here, everything to the right is considered positive, everything to the left is considered negative. So displacements can be positive or negative. Distances can only be positive. And then same thing, average speed. Average speed is defined to be distance over time. So average speeds are always positive because time's always positive and distance is always positive. But average velocity, and I'm going to say this again as we go to the other ones, because I know we haven't, but average velocity is defined to be displacement over time. So average velocities can be negative or positive. Velocity can be negative. That surprises people at first. A negative velocity does not mean, so I'm saying this to everybody, just like based on Mark's question. I mean, I know he was just asking like about my handwriting, but I'm glad he noted that. Velocities totally can be negative, and that can be confusing or weird at first. I just want to tell everybody to have a negative velocity does not mean slowing down. And it doesn't mean doing some weird, like going back in time. It doesn't mean you're like Michael J. Fox or the flux capacitor or something like that. Negative velocity just means a velocity in a particular direction. Like if positive velocity means going north, then negative velocity just means going south. But yeah, so those 2 answers, so they're not always negative, but they are in this case. Fundamentally, because in this case of the problem, where all those 4 questions right there are asking about what the instructor did overall in the full 8 seconds of the entire situation. And in that situation, for the whole situation, the instructor, and this is where I should be putting out a diagram, and I guess I will in a moment, but the professor or the instructor in the problem of homework 1, and I hope all of you sort of have it in front of you right now, like that would be good, and I would put it up on the screen, but then you can't see this screen and yada, yada, yada. But the instructor starts at position +4. And after all the shenanigans, the professor ends up at position -5. Like there are a lot of shenanigans, but the ultimate point is the professor starts over here at +4, ends up at -5. So all told, the professor is displaced 9 in the negative direction. If it had gone the other way, then we would call it positive, but the professor went from right to left, all told. So we said, or the instructor, so we say there was a negative displacement for that time interval. And therefore, when we divide by time, we get a negative average velocity for that interval. But okay, good question. That was, and you get points for that, and I'll shut up. All right, so now I'm going to move on to, we have 15 minutes. Okay, and again, we don't have class this Wednesday. We do have class Monday. So I'm going to move on to the rest now. There was no video about this. So I'm going to try to act like you, like doing my homework now, right? So I'm going to draw a diagram. I'm going to be fair about this. I just, in theory, did those sort of quickly because you'd already seen those. But so now, oh yeah, okay. So here, so I have my diagram at the top. Oh, sorry. Oh, I think, wait, unless I'm wrong, I think we have no school Wednesday, right? Sorry, someone just asked in direct chat, but I'm glad they are. I believe we have no school at all Wednesday and Thursday. It's not because of physics. It's like John Jay, I think. Maybe someone can confirm? Can anybody confirm?
We don't have class on this Wednesday.
Thank you. Okay, right. So there's no, and by the way, I mean, to get the elephant out of the room, it is, yes. So it's for, right. Okay. So by the way, thank you. Oh yeah. Okay, cool. Thank you, Leslie. And thank you, Rachel. And just to be awkward for a moment, like, I don't know why it's such a hard, like, so these are in honor to observe holidays that come from a religion, which is mine. I mean, it is the religion that I was brought up in. I mean, so I should be the first person telling you this and knowing this calendar. But obviously it's some sort of like self-neurosis in me that I don't, but yeah, it's for Yom Kippur. So we don't have school. Right. Okay. So, and all those of you who are observing, I wish you the best. And those of you who are benefiting from alternate side of the street parking, I wish you the best. Okay. Anyway, so we don't have school. All right. So here's my diagram. So I'm just like doing the homework now, right? Like I'm like starting from question 5 as though it's the beginning of the homework. So I give you a diagram. Now, please notice, I don't want to over talk this too late. But notice I give you a diagram here that's very similar to the diagram in the actual homework. It contains all the same information. It's very similar, and it may even be similar to the same diagram I put on the YouTube video, but it's a little different because I just drew it like today. Like it contains all the same information, but it's a little bit different, thus showing I really have the information in my brain. I didn't just like literally copy this. I put down what I thought was relevant and in a slightly new way, right? But there's the whole situation. Like the professor first goes, and then he goes, and then he goes, right? And it's like 3 seconds and then 2 seconds. Your diagram doesn't have to be presented quite that way, but it is the relevant information. And do notice that, at least in this situation, we've decided that everything to the right of 0 is called positive. Like anything that is or goes to the right of 0, we're going to call positive. And anything that is or to the left of 0, we call negative. And that completes the entire set of possibilities of direction because we're in one dimension. We have one degree of freedom. It's either that way or that way, whatever you call it, whether it's north, south, left, right, forward, backward. In math, the easiest way to keep track is just positive, negative. All right, anyway, so that's my diagram. Then question 5, the question is, what is the average speed? I don't even remember how it's exactly phrased in the homework, but the homework basically says, what's the average speed for the first 5 seconds of the journey? So I jotted it down. I just jotted it. It's not formal. It's an abbreviation, but it just shows I know the question. The question is, what's the average speed from t equals 0 to t equals 5? And note, we're still in the land of like speed and distance are kind of softer. The concepts of speed and distance, the ones that don't care about directions, are the ones that we build displacement and velocity from. So the concepts that don't have directions are a little bit less formal. And ultimately in physics, we really care about the ones with directions. So ultimately we have symbols and letters and equations for things like velocity and displacement. We don't really for speed and distance. That's why I'm still kind of in English here. Okay. I mean, we're going to get out of English soon enough. But I wrote down the question, what's the average speed from t equals 0 to t equals 5? So that's WIQ. What is the question? So I've done 2 steps now. I've done the diagram. I've done what is the question. Now notice, I'm asking for average speed. So I give you a triple equal sign. Average speed equals distance over time. Always true. Even if I can't figure out the distance here, it's always true. So if this were an exam, I would get points for that. Like, please look at this the other way too. Don't think of it as where I punish you for not doing things. Think of it as where you get points for doing things, even if you don't know the answer. Average speed equals distance over time. It's always true. It's a definition. It can't be wrong. So it can't lose you points. So I wrote it down. Then I go to double equal sign. I apply. So that was GDP. That was step C of this method of doing homework or solving problems. Now I'm at step D. So maybe I should even, sorry, I don't want to. So this was like step A, this is step B of the method. I mean, this is step C, this is step D, right? In other words, this is diagram, fact, pattern. This is general definitions and principles. This, it's not. This is what is the question. This is general definitions and principles. And now here is where I'm applying to the particular problems I'm doing. So this is particular application and work, right? Again, this step D is a step that everybody tends to do. They tend to hop right to that one, but that's what that is. And then, so I got the distance, I got the time, I plugged them in. So, oh, sorry, Ruby, question?
Oh, yeah, I had a question. So what was the word above the letter B?
Oh, WIQ, you, wait, oh, sorry, but WIQ, is that what you're asking?
No, I meant the one that's, I don't know if it's an FROM, from.
Oh, from, yeah, I'm sorry, that says from, yes, okay, I'm an axe murderer, yes, sorry, yeah, hold on, yeah, that's supposed to say from. Yeah, so what's the average speed from t equals 0 to t equals 5? Does that make sense?
Thank you.
Thank you. Good question. Awesome. Okay. So, and then there's something in the chat. Oh, okay. Right. Got the chat. Okay. Okay. Cool. 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 All right. So then, all right. So now I'm plugging in the numbers. Again, I'm trying to emphasize here, like, I know we all think physics is about plugging in. Well, I don't know what we think. People think science often is about plugging into equations. I'm saying really doing science is about developing the equations in the first place, right? There's stuff you got to do to get the equations to put them down. The plugging and chugging part is actually, once you're already up to the plugging and chugging part, that's the easy part in a way. Like that's the machine. I shouldn't say easy, but that's when the machine's just going. So anyway, so now I plug in the numbers. So then I have my final answer. My final answer is average. And notice it's an answer. It's not just like 2.4. The question was, what is the average speed? So the answer is the average speed is equal to 2.4 feet per second. It has an equal sign in it, a double equal sign. It has units in it. It's the final answer to the question. And it's like highlighted and circled and like there's like neon lights. Yay, whoa, right? So like, and again, I mean, hopefully the question wasn't that hard for most of you. And again, if you're thinking like, boy, did you drag that out, Yaverbaum? Yes, I did. Because your brain actually did have to do that many steps. I'm just slowing down the mental movie so that we have one to run when we don't know what to do, right? But just notice how clean it's like book it. Like it starts with a question. What is the average speed from t equals 0 to t equals 5? And it ends with an answer. The average speed is 2.4 feet per second. That's a mini research project right there. Like granted, it was a homework assignment, but I'm saying like any journal article, any poster presentation, anything you do in the world, like starts with a research question and then you do a bunch of stuff and you get an answer. And like it is really like an important skill to be able to say to the world, this is what just happened. So they know how to read it. And so that they know that you know what you did anyway. Okay, you get it. So that's the answer to that one. Should I say this? Okay, no, I'm not going to say it. One of the reasons I'm so hyped. Look, every 5 years, every department in the school has to present a self-evaluation of itself to the outside world. Every 5 years, every academic department in the school has to write this huge, compile all this data and write this huge long report answering all these questions about what they're doing as a department, how they do it, how they've been growing, and they have to present it to like outside reviewers and stuff, right? It's a lot of work. And this is the year that my department is doing that, and I'm the head of the committee or whatever. So I've got all of these. I'm just telling you guys just as a thing, okay, just as perspective. And this is in the real world, right? Like if our department doesn't like do what they're supposed to do this way, then other departments could say we stink and then like we fold, and we don't get funding and you don't have a school and blah, 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 right? So there's we've been working on this thing for months and months and months. We've been holding committee meetings like every 2 weeks in the middle of summer, and all these people do these drafts and they submit it to me, and then I have to put them all together, and I'm the one editing all the, for I don't know what, for whatever reason, I'm the one editing all the writing of this big self-evaluation of what we do as a department that we have to hand to outside reviewers. Okay, can I just say, it's a freaking mess. Like, it's an embarrassment. And these are all really smart people in my department. Like, I totally respect my department and my colleagues, but, and all they're being asked to do, all we're being asked to do is tell the world what we do, like what courses we teach and like how we teach them and what the curriculum, like we have all the facts, but this document that we're putting together is like a nightmare because everybody thinks it's so obvious, they don't know how to say it. Everybody's like, yeah, we know what we do. Do we really have to say it? Well, just say it then. But like the easier something seems to people, the harder they make it in some way. I'm just saying, I'm not criticizing any of you. I'm trying to tell you, like, even as scientists, like we need to break, or especially as scientists, we have a duty to break down what we're doing and make it clear to ourselves and to others. Otherwise, like the country, blah, blah, Fauci, blah, blah, yada, yada. Like, you know where I'm like, I don't need to tell you. Like people look to science all the time as like the black magic wizards that are going to solve all the problems. And we better have something to say. Anyway, whatever. All right, so that's the answer to that one. I don't know what I'm sorry. Just okay. So that's question 5. Then question 6. So then question 6, it asks, now I don't have to keep doing the diagram every time. I can say C above diagram or whatever. Like I've given the fact pattern. Now question 6 is, what's the average velocity for t equals 0? I should say from, like Ruby's question, sorry, from t equals 0 to t equals 5. And this is probably the last one we're going to do today. I understand that. Wait, what time? Oh, yeah, we like 2 minutes. All right. Just note, now we can start using equations. And this was what the video was about, I believe, or 2 weeks ago. I actually started giving like V with a bar over it means average velocity. X minus X naught means final position. And maybe I should go back over this more slowly next class, but since we have 1 minute left, I think this was all in the video or 2 weeks ago. Like once we're now into the land of velocity, that equation that I wrote there is not a formula. It's not black magic. It's just the definition of average velocity, but written in symbols, right? Average velocity is the displacement, the final position minus the initial position over the final time minus the initial time. But the initial time is always by definition 0. So that equation we didn't discover in a lab. It's just our definition in symbols for average velocity. So I wrote it down, and this is where we're going to end, right? Then I plugged in the numbers, like X, the final position was position 4, the initial position was 4, the time was 5. So I plugged it in and I got 0 over 5, which is of course 0. So, and this is where we're going to end. I know it's 4. Yeah, it's just about 420. So average velocity for the whole journey was 0 feet per second. And just pause for a second. Like, so we took this whole crazy journey, the average speed, or a portion of the journey for 5 of those seconds, the average speed was this high number of I don't even remember anymore. I forgot. Was this? I don't even remember. Sorry. Oh, it was 2.4 feet per second. But the average velocity, even though we were moving fast the whole time, the average velocity was 0 because we didn't get anywhere, because we ended up where we started. And that's called a round trip. Even if you don't literally go around, even if you're in one dimension, anytime you end up where you start, it's called a round trip. And by definition of average velocity, anytime you do a round trip in physics, no matter how fast you think you were going speed-wise, your average velocity will always be 0 feet per second. It's not a contradiction. It's not a weird psychedelic thing. It's just a precise meaning of the word. That's where we're going to end right there. We will start going faster and faster. We will go through more of the rest of the homeworks. And yet, the game. Yeah, and thank you. You could totally go. I'm just going to hang out for any questions right now for a couple minutes. So thank you very much. But wait, soon. Yes. As long as you hand in the game turn anytime before midnight tonight, you get full credit. That's correct. Yes. Have a wonderful day. You guys are awesome. Yes. I'm just going to hang out in case there are questions. But yes, you guys are good to go. Thank you so much. Thank you. Awesome. Thank you. Okay.
Professor?
Yes.
One more question. So
Yeah.
when you write like